Hi guys. So today we are going to discuss about Toivonen algorithm. So let us get started with the algorithm first. Toivonen's algorithm is a simple algorithm for finding out the frequent item sets in the given sample. So we take a sample and find the item sets that are frequent in the sample. It is necessary that we lower the threshold value so that there is a little chance of getting a false negative. For example, here we use a 1% sample of the set, but divided by 125. I mean, divide the threshold by 125 and consider any item set that met or exceeded that reduced support threshold to be a candidate set. Um, so now our main goal here is to prevent the false negatives and ensure that items are very frequent. We calculate the items which are frequent. So how do we calculate the frequent items? If an item has a support that is close to the support threshold but is not equal or greater than, then it is considered as the frequent item. So this is how we calculate frequent in this algorithm. So next comes negative border. So what is negative border? When a set or a basket is not frequent in the sample, but to all of its neighbors. I mean to all of its immediate subsets. So for example, we take a set of four items A, B, C, D in the negative border if it satisfies two conditions. First, it must not itself be frequent. No set that is frequent can be in the negative border. And the next is, but all of the immediate subsets, the sets which we get by deleting one of the element or the item in the set are frequent. So these two are the conditions for the negative border. So next comes the second pass. So in the second pass, we count all the frequent items from the first pass. So that is the frequent algorithms we discussed before, the negative frequent items before the negative border, and then also the negative border items. So here, if there is a negative border as a frequent item set, then we have to start over with a different support of threshold value. So we have to keep changing the threshold value until we get the frequent items which are not in the negative border. So, as discussed before, so what if we find something in the negative order that is actually frequent? So then we have to start over again with another sample. We have to choose the threshold. So the probability of failure is low, while the number of items are checked on the second pass with the main memory. So basically, we have to repeat the steps which we did earlier. So this picture shows the negative border. I mean, if an item set is found in the frequent item set is found in the negative border. So if it's just an item set found in the negative border, then we can just ignore it. But if we found the entire subset of the given set in the negative border, then there is no other option to reiterate the entire process with another subset, or changing the threshold value, because there is no limit to the problem. So we have to definitely reiterate the complete set, or with a new set taking a new threshold value. Since you guys have a brief understanding on what is negative border and what are frequent items in the given sample, so this is just a theorem to take home. So what is Toivonen theorem? There is a member of the negative border for the sample that is frequent in the whole if an item set is frequent in the whole but not in the sample. So what that means? That means we want to know if there is any item set at all that is frequent in the whole but not frequent in the sample. And there are few members in the negative order that is frequent in the whole but not frequent in the sample. So basically we want to find the frequent items which are not in the negative order but frequent in the whole given set. So this is the last slide of our presentation, which is proof. We'll prove this algorithm by method of contradiction. So we say the statement as false and proceed with the proof. So here our statement is there is an item S that is frequent in the whole but not in the sample, and nothing in the negative border was found to be frequent in the whole. So this is the statement. Let us start with the proof, contradicting proof. So let T be one of the smallest subset of S that is not frequent in the sample. By the principle, T could be S itself if it has no proper subsets that are not frequent in the sample. So now we only care about the subsets of T that are frequent in the sample, right? Um, and the next step is here we say that T is frequent in the whole. Um, so if T is frequent in the whole, then by monotonicity, each of S subsets are frequent in the whole, right? And T is one of the subsets. So in the next step, we say that T is in the negative border, and it is not frequent in the sample. So, but it had a proper subset that was not frequent in the sample. Then T would not be the smallest subset of S with that property, right? So that's a statement. That statement is contradicting, right? So because we started with saying that there is nothing in the negative border, but now at the end we are having frequent in the whole, and now we see that T is both in the frequent and frequent in the whole and also in the negative border. So since the statement is contradicting, we can say that Toy-Evenance algorithms gives the truth.